This is our next exponent lesson, and it is called power to a power. So some of these outside exponents didn't get written outside of the parentheses very well, so I apologize about that. So anyway, the way it works is if you ever have an exponent and you raise it to another exponent, you multiply the exponents. So A times B, which I can just smush them together because that means multiplication. So, for example, if I had x to the 4th all raised to the 6th, anytime I have an exponent raised to another exponent, I multiply the exponents. So I keep the base, whatever that is, and I multiply the exponents, and 4 times 6 is 24. So the answer would be x to the 24th. Okay, so I raise the exponent to the power, and I multiply the exponents. And if you have more than one thing in the parentheses, everything gets raised to that outside exponent. So let's look at number 1. X is my base, exponent raised to exponent, so I multiply the exponents. And how much is 4 times 5? 20. So the answer is x to the 20th. Now number 2 has a coefficient. So first I take 2 to the 4th power. And then when I take x to the 4th, I keep the base. And then I multiply the exponents. And 4 times 4 will make 16. And I'm going to fix that in just a second. Then I take y to that power. So I keep the base, and I multiply the exponents, 3 times 4. And then I take z, and I raise it to the 4th. And so that's just z to the 4th. So let's clean it up. 2 to the 4th means 2 times 2 times 2 times 2, 4 times. And how much is that? 16. And then 4 times 4 is 16. 3 times 4 is 12, and then I just recopy z to the 4th. And there's my final answer. Okay, number 3. First I take the negative 4th to the 3rd power, so I'm going to put the negative 4 in parentheses and raise that to the 3rd power, and I'll clean that up in a second. Then I raise m to the 3rd power, and then I raise n to the 3rd power. Well, negative 4 to the 3rd power means negative 4 times negative 4 times negative 4. And how much is that? Negative 4 times negative 4 is 16, and 16 times negative 4 is a negative 64. And then I can't do anything with the m to the 3rd or the n to the 3rd, so I just recopy those. Okay, number 4. First I take the 3 to the 2nd power. And what is 3 raised to the 2nd power? 3 times 3 is 9. Then I take x to the 3rd to the 2nd. So exponent to exponent, I multiply my exponents. And how much is 3 times 2? 6. Okay, then I'm going to put the plus sign. Next I take 4 to the 2nd power. So how much is 4 to the 2nd power? 4 times 4? 16. And then x squared to the 2nd, power to power, I multiply the exponents, and 2 times 2 makes 4. Okay, and then if these were like terms, I could add them, but since this is x to the 6th and this is x to the 4th, I can't do anything else here, so that's my final answer. Okay, number 5. First I'm going to take the 1/3 to the 3rd power, so I'm just going to write this off to the side. 1/3 to the 3rd power, which means to multiply 1/3 times 1/3 times 1/3. So I multiply my numerators and my denominators, and that makes 1 over 3 times 3 times 3, 27. And then p gets raised to the 3rd, q gets raised to the 3rd. I'm going to put that all back in parentheses because I need to multiply it with what's over here. So now I take 3 to the second, and 3 to the second makes 9. Exponent to exponent, multiply the exponents. 3 times 2 is 6, so p to the sixth. Exponent to exponent, multiply the exponents, and 4 times 2 is 8. Okay, now I can clean this up. Since I'm multiplying, I'm going to start by multiplying my coefficients. I need to figure out what 1 over 27 times 9 is. Let me do that over here. 1 over 27 times 9, which is understood to be over 1. Let's go straight across, and I get 9 over 27. And what is 9 over 27 reduced to be? 1/3. Okay, so I get a 1/3. Then I'm going to go to multiply my p's. Remember we learned the other day, whenever you're multiplying the same base, you add the exponents. So I keep my base of p, and I add the exponents. 3 plus 6, which is 9. And then when I go to multiply my q's, I keep that same base, and I add the exponents. 3 plus 8 makes 11. And there's my answer. 1/3 p to the 9th, q to the 11th. Now number 6, I could do this a variety of ways. I could take everything and raise it to the 3rd power and then square that. Or I could take this power to this power and go ahead and multiply those exponents. So I'm just going to go ahead and take everything to this 3rd power first, just because order of operations says do what's in your parentheses or your brackets first. So I'm going to take -2 and raise it to the 3rd, which is -2 times -2 times -2. And how much is that? -8. And then x squared to the 3rd, I multiply my exponents. 2 times 3 makes 6. Okay, and then I still need to square all of this. So now I'm going to take -8 to the 2nd power. So -8 to the 2nd power, -8 times -8 makes 64. And then when I raise x to the 6th to the 2nd, exponent to exponent, I multiply the exponents, and 6 times 2 makes 12. So sometimes students get confused why I'm not multiplying the -8 times 2 and get a -16 here, but that's because -8 isn't an exponent. I multiply the 6 and the 2 because they're both exponents, and when you raise an exponent to an exponent, you multiply the exponents. But -8's not an exponent, so it just gets raised to the 2nd power, like that right there. Okay, if we have an outside exponent with division, everything goes to that outside exponent. A gets raised to the nth, then I recopy the division bar, and then B gets raised to the nth power. So everything still goes to the outside exponent, we just still have a division bar there. So let's look at number 7. -3 is getting raised to the 2nd, so -3 raised to the 2nd, -3 times -3, which is 9, division bar, and then the 4th gets raised to the 2nd. And how much is 4 squared? 16. If I could reduce this, I would, but there's nothing that goes both into 9 and 16 besides a 1, so we're done here. Okay, number 8, I'm going to go ahead and I'm going to take everything to the outside exponent. So when I raise an exponent to an exponent, I multiply the exponents, division bar. Now a squared gets raised to the 3rd, exponent to exponent, multiply exponents, so a to the 6th. And then I take b to the -2 to the 3rd, exponent to exponent, multiply exponents, so b to the -6. Now I do have some stuff I can clean up here. You can't ever leave more than one a in a problem, more than one b, more than one c. So when I'm dividing the same base, what was the rule with the exponents? Subtract. And 12 minus 6 makes 6. And then you can't ever leave something with a negative exponent. So if it has a negative exponent, I have to move it. So since it's a negative exponent in the denominator, it's going to go up to the top. So now it's going to be up in the top with my a to the 6th. And there's my answer. And that's it. Smiley face. We're done.